Our next speaker is Larry Morgan. Larry's a scientist here in Green Bank, and he will be walking us through an introduction to Astrid, which is the actual interface you will use to submit observations.
Hey, thanks, Will. As Dave mentioned earlier, normally we try to be quite interactive with these sessions, and if we were all in person, I'd probably be asking for a show of hands for certain questions and just asking people to butt in with any questions they might have. That's a little harder to do in our current format. So, and I'm not going to be able to see the chat window while I'm talking. So please just unmute yourself and butt in if there's anything you need clarifying or so on. And Dave already went through quite a bit of the the mapping techniques and so on you might want to use. So as Will said, I'm just going to give you an introduction to that actual interface through which you'll actually be able to enact all of those things. And my plan is to actually walk you through it on my screen rather than giving you another PowerPoint presentation, though I do have slides that you'll be able to access after the talk. And hopefully this will allow me to answer any questions you have as we go. So just one slide I'm going to show you. It's just to point out some of the terms I'll be using. So Astrid is the Astronomer's Integrated Desktop, which is our GUI for controlling the GBT, and nominally for monitoring observations, though it's sort of a broad overview and more detailed monitoring is usually done through Clio, which Amber will be talking to you about after my talk. I'm going to be talking about scheduling blocks, which I'll probably use interchangeably with scripts, which is just our list of observing commands submitted through Astrid, which is written largely in Python. And the scheduling block will often contain a configuration, which is the set of parameters you are sending to the GBT to set it up for your type of observation. And Clio is our essentially another GUI, but with a lot more complication. And it's a very complex system with the sort of managers and windows for each subsystem of the GBT. And a lot of that is at the expert control level. And the one thing I will probably point out to you is the talk and draw, which you'll use when you're observing, especially when you're remote observing, to chat to the telescope operator and anyone else who might be online that you need to speak to. So let's see if I can share my, this is my VNC screen into the GBT system. So I'm just going to start up Astrid, which we do by typing Astrid. It'll just take a few seconds to start this up. So I do this all in real time, of course. So this is Astrid. There's quite a lot to it to begin with, though it's all pretty straightforward once we start. The first thing you would do when starting up Astrid is select your project. And I'm just going to select an old project of mine that I know has a script in there that I want to show. Oh. Firstly, you have to select your real-time mode. So if you were actually observing, you would select work online with control of the telescope. While you're waiting for your observations to come up, you might want to only monitor the observations. In this case, I'm just going to work offline and then select my project. So you go to the GBT, which is generally the accepted proposal project repository. Go to the semester you want, and then find your project code. And there we go. Now, if you select a script in here, you'll see our editor window. And this has useful highlighting and so on of the Python syntax. And I'll go through the scripts a bit later if we have time. The scripting was not necessarily the primary goal of this talk, but rather just getting you used to and familiar with Astrid itself. So let's see. Here we have, this is the tab for observation management. So this is where you'll spend most of your time. You have your script editing window, the list of scheduling blocks available to you to edit. And if they, well, I'll come back to that. And here you have your normal sort of expected script interaction buttons. So you have save, delete, import, and export to file. So if you like, you can edit your scripts in an external editor. Once you have a script written, this validator, which Dave mentioned, will tell you if your script is able to run on the telescope or not using a simulated configuration. So it's quite possible to validate a script and then have it not run on the telescope. But don't worry about that for now. I haven't got my scaling right here, I'm afraid. Okay, that might be better. Okay, so this script is validated. So you should be good to go. And then in which case you would switch to this Run tab. Again, you would need to select your project. And your session will automatically update here. Sometimes you'll see a message telling you that you should increment your session ID. This is quite important for saving your data in the archive so that you can access it later. So always make sure your session number is correct. And then you would type in your observer name here. And I'm not sure who the operator is right now, but let's assume it's Dave. We'll put in the operator there. And then if you were to try and, if you're actually on the telescope, you'd select the script you want and you could either just double click that. I'm assuming that these buttons are grayed out because I don't actually have access control of the telescope right now. Or you could click submit and you can actually line up several of these scripts into the run queue so they would just run one after the other. And then in this observation management log, you'd get messages from the telescope telling you what's happening, whether you're configuring the telescope, and so on. Now, here are the status indicators for the telescope. So the observation state is not connected, but if you were observing, it would tell you that things are proceeding okay. And this is where you might see some errors, or everything's going okay. These buttons are very important for queue control. So halt queue would allow, say you put in here your peak focus script followed by an observation script followed by a calibration script. You could hit halt queue and that would stop the observing process after the next script is complete, allowing you to make some alterations or do whatever you needed to do. The pause button stops the current scheduling block when it reaches the next line of code, so it won't actually interrupt the scan you're currently doing, but will, it's kind of like a breakpoint, will stop the execution of the scheduling block at the next opportune moment. Stop will stop the telescope at the end of the next integration time, so could actually stop things halfway through a scan, but at the end of an integration time, so you won't be at risk of corrupting any data. Abort means stop immediately, and that could potentially corrupt some data. So you should only reuse that if you're sure that everything's going badly and the data you're currently observing is going to be useless anyway. This interactive button, occasionally Astrid will throw up pop-up queries, usually ones you've put in yourself into your scripts. And there's a timeout session for that. So Astrid will automatically answer those questions for you with the safest answer if you unclick that interactive button. So if you were going for lunch or something and you were leaving the telescope running with the operator's blessing, of course, then you would do that. Right, so moving through these tabs, we can move on to the data display tab. Now, a nice feature of Astrid is you can actually open old observations and have a look. So let's go and look at my session that I actually observed with this project a while ago. And I can show you some more of the data display tab. And if you just click on scanlog.fits, that'll bring up all the observations that you actually observed in that session. And you can see here there's a bunch of different types of observations. There's pointing, focus, OOFs, which Dave mentioned, continuum obs, and spectral line obs. The spectral line tab is actually not very functional, and any kind of quick look you want to do for your data in spectral line should be done through GBT IDL, which you'll be becoming more familiar with throughout the next few days. Actually, let's just take a quick look at the NOOF map. Oh, what's going on here? Well, so that's you may have opened the wrong project. Sorry, folks, for the joy of doing things in real time. So here is a pointing scan. You do 2 scans in azimuth back and forth. You do 2 in elevation back and forth. And as you can see, you've got your nice peak data and your peak pointing solution in your data display log down here. That's something that might be important to you if you're observing a high frequency, especially, is the ability to go into this tools menu and go to options and tell it how good you want the fits to be before you'll accept them for your pointings. So here we have automatically accept good fits, automatically reject bad fits. There's these pop-up messages that will help you determine what you're looking for there. There's also this heuristics tab, which if you're at, especially if you're observing the KFPA, you might want to make those heuristics relaxed. There's also a data processing option where you have total power raw. Depending on the receiver you're using, you may actually see some more options there. But as you see, there's the pointing solutions have come up, and those would normally be you'd be prompted to say whether you accept those or not, depending on your settings through the fitting acceptance criteria I just showed you. Here's our focus scan, and then I can actually show you an OOF map that you won't get to do, but may be of interest to some of you who are looking at higher frequency observations. Someone else is going to talk to you more about what OOFing does and how it works, but that's what the data looks like. Now, the GBT status tab gives you some basic information about what the telescope is currently doing. This will be, not sure if this is the person who's actually observing right now. I guess it is, because that's the right time. So even though I'm not technically monitoring observations, we still have up-to-date information in the GBT status window. And it just gives you things like the as, now, the quadrant detector RMS, so on. There's quite a lot of information in here, including some balanced information, so you can look at what the power levels going into Vegas are like, giving you some idea of how the system is balanced, and so on. Now, anything else I wanted to talk to you about? Yeah. So I'm going to switch back to my slides for the time being. And I'll maybe get a little more into the ins and outs of what the scripts look like and so on, what you're actually going to be using Astrid for. So I think I gave you most of this information. So yeah, I believe I didn't really, so I guess I did actually tell you about submitting these scripts. They show up in the run queue, and then as they're being run, they show up in the session history window. So this is talk and draw in Clio. I won't actually connect to it, as when you do, there's a loud noise in the operator's computer in the operating room, and you probably don't want to annoy them. But yeah, if you start up Clio, you can go through the Clio menu to find Observer Tools, go to Talk and Draw. This will start that up, and then you'll have a direct line of communication to the operator in the operating room, in the control room. And you'll be able to talk to the operator, find out what's going on, find out when you're ready to observe, when the last person is going to be done. Ask the operator to put you in the gateway, which is when you'll have full control of the telescope, and so on. So this brings me to a bit more detail about the scheduling blocks themselves. The first thing you want to do is define your catalog. You need to tell the telescope where you're going to want to point it. And the most basic way of doing that is to set up a catalog with just an object name and an object name and a set of coordinates. So here we have just a very simple catalog with the name, RA, and DEC of several objects in there. You can actually put in a lot more parameters than that. As you can see in the slightly more complicated version below, where we have a rest frequency, a velocity, a type of object, and you can use and access these parameters within your Astrid scripts, your scheduling blocks, to define certain things. So you can just use that to automatically set your LO for the VLSR of your object, or you can use the type to cycle through types of objects in your observations, however you want to do it. The next thing we're going to want to do is tell Astrid how you're actually going to be setting up the telescope. And here's a configuration I lifted straight from the observer's guide. Gives you just fairly basic start to how you might want to configure the telescope at L-band. You can see we're setting up the receiver. Well, I'll get more into these in a minute. In the observer's guide, we actually recommend that you store your configuration in an external file, which saves time in the short run, because then if you change your configuration, you're not having to save and validate your scheduling block each time you change it. So when you're first setting up your observations and you're not quite sure your configuration is 100% correct, and you're aware that you might need to do a little test observation before you're convinced your configuration is correct, then maybe that is a good idea, because you might otherwise be validating your script multiple times, and it's going to save you some time. However, with that configuration in an external file, when we're then trying to track down any problems that might occur during your observing run, it makes diagnosing any problems more difficult, because that data and those parameters are not stored in our logs. And we can then, we can find the location of that external file as it was at the time, but if you've changed that location, or if you've changed the file itself, we're not able to explore that. And so once you've established that you're going to go ahead with your configuration as is, I recommend putting it in your script itself, so that we can trace back any problems later on. Of course, you might end up having 10 different configurations that you're going to be using during your observing run, so it's not always practical, but yeah. One thing to point out is if you're going to store that file externally, don't import it, use exec file, because import will not reread the file if you change it externally. So as Dave pointed out, there's a lot of flexibility in the GBT. The observing ranges from below 1 gigahertz to 116 gigahertz. That encompasses a lot of different observing methods and techniques. There's a lot of different subsystems that might come into play. And so that flexibility brings a lot of complication. And so that means you should understand what your configuration is actually doing. There shouldn't be any parameter in your configuration that you don't at least have some idea of what it's actually doing. There are no, while a lot of the parameters have defaults, those defaults aren't always sensible for what you want to do, depending on what it is you want to do. So you should make sure you know what each of them are doing. These are all highly specific to the project, as I just intimated. And they're pretty much straightforward. So, your receiver keyword, hopefully you know which receiver you're going to be using, so you're not going to have to spend too much time worrying about that. Same with your rest frequency, backend, and so on. This switch mode might be a little more elusive. And so we have this SP, which is actually one of the less used modes, potentially, and that's switched power. That's usually used for frequency switching, but we also do beam switching. You can actually do polarization switching as well. So there are different reasons you might want that in there. If you're not switching power, you're using total power. And you also have the option there to turn off the diodes, which are used for calibration. So half the time you're observing, your noise diode is on, helping you to calibrate your system. And I won't get too much into calibration modes, and I'm sure there's another talk about that. And yeah, as I said, and the switching type, you can be frequency switching, beam switching, or polarization switching. You can set your switch frequency and so on, and your switch cadence. And as I said, your diode calibrator will be firing for half the time you're observing, and you often have a choice of a low or a high temperature diode. And for receivers below 12 gigahertz, we have a low and a high, which the low is approximately a tenth of the TSYS level. Whereas higher frequency receivers usually have more specialized arrangements where on the KA, I know we have different diodes depending on the polarization you're using. The KFPA has variable diodes. And so if you're using one of those receivers, you should investigate those options more carefully. As has been mentioned, the scripts are essentially Python, though there are a lot of self-contained Astrid functions commands. I'm not going to be teaching you Python in the next 20 minutes or so. It's not necessary to know a great deal of Python to operate the telescope. And most of the information you'll require is in the observer's guide, and certainly your observing friend will be able to help you get your scripts going. As I've already alluded to, the first thing you want to do is give Astrid the positions of your sources by including a catalog. You can also just define the location of a particular object if you're not going to be observing many objects. You want to give Astrid your configuration, which I've already talked about. And then it's up to you to balance the system and get any system feedback you might need before you start taking data. So let me go into this in a little more detail. So here's the script I was showing you from my project earlier, which is this script here. I've tried to copy this formatting from Astrid over to my PowerPoint with its different colors. So the first thing I've done here is specify a catalog, and this was a W-band project using Argus. So I loaded up the catalog with the W-band pointing sources in it, so that Astrid then has access to all of the sources within that, and I can just refer to those by name. You can see here, hopefully you can see my cursor. I've defined a point source here, which is a well-known pointing source, and that if I hadn't included this catalog, this name would not be recognized. I've also defined my own catalog, which allows me to access these names, but also allows me to access the columns within my catalog. as I showed you earlier, we have these columns here, and I can directly reference those by assigning my catalog to a variable here. And that's what I've done here. So this is sub-referencing that catalog. What's nice in Astrid in this way is we can use these objects in arithmetic. So I have an off position within my catalog, and I can define my offset by subtracting my off position from my source position. And if you want to check something like that, what's nice is that if you have a print command in your script, when you validate your script, those print commands will be run, so you can actually check things like your arithmetic and so on, just to make sure your coding is correct, without the need for a simulator or anything like that. So as I said, this is your, you want to run an exec file command to get your configuration in, which is what I've done there. And that just loads up the essentially the Python dictionary or keyword parameter pairs. And then you actually have to run a configure command to load those up. You then normally slew to your source or not, depending on how you want to configure the system. So balancing the system is setting all the power levels to optimally collect data, so that everything's within the right gain level, gain parameter. Everything is within the right realm within specs for the system. And if you're looking at a very bright source, if you were to balance the system off source and then try to observe that source, you might actually then move out of that optimal power range. And so often you might want to balance on source so that you're sure you're getting the right power levels. We also have an option to balance on and off the source and then split the difference, if that's something you need to do, if you're observing a quasar or something like that, or a very bright maser. Now this is a bit of a specialized use of Astrid, that a lot of you probably won't need to do, but it's useful to know that you can communicate with the system to retrieve vital information, retrieve specific information from the samplers or the IFs, the LO, whatever you need. And as I said, these print statements will run when you validate the script. Though if you are going to do that, the retrieved values may not be the real ones because they'll be coming from the simulated configuration. A very useful feature of Astrid is this break command. So as you're observing, what I've done here is slew to my source, I've balanced, and then I've asked the system to give me some feedback. And then because I don't want to just carry on observing without checking that feedback's okay, in case I need to make some alterations to the system, I've put this break in, and that will make a pop up in Astrid, and it won't continue depending on my settings in Astrid until I say okay, or until it times out. So then that would give me the opportunity to have a look through Clio, have a look through the GBT status window and check that everything's okay before I say okay and continue. There's this external script, which again, this is a specialized use for Argus, where we're running a special calibration script. You wouldn't normally do this, though I did want to point out that you can run external scripts through Astrid, but please don't. Most of the time, you would only want to do this if your friend had specifically recommended it and helped you set that up. And then here's our observation procedure. This is one of the more slightly complicated ones, where you have it's a full map with an off specified. And I'm not going to get too much into those because they're fairly highly specialized, and there's quite a few of them. We don't want to overload you too much at the moment. We'll save that for later. So yeah, there's a lot of useful internal functions, which again gives us a lot of flexibility, but also allows for a lot of complexity. So as I said, the break command will allow you to continue or abort your scheduling block. If you write a comment, this is different to simply putting a hashtag comment. If you write the function comment and put a comment in there, that will actually insert the comment into your observing log, which can be helpful for any diagnosis at the post observation. We have some functions like get UTC, get LST, and any of you familiar with Python will know there are some powerful, though tricky to use, time calculations that you can perform, and they can come in very handy when you're dealing with a lot of sources that you're trying to make sure you know the rise and set times for, and so on. I guess now is also another one of these commands that will return the current time. Wait for will also help you to set up some scheduling within your script if necessary. Change attenuation is again related to the power levels of the system. If you're actually needing to change any of those or mess around with the IF rack, anything like that. Another useful function is this horizon function. It gives you the rise and set time of the location you give it, which can be just a source you've defined. And then you can actually use that to start and stop observations when your source passes a given elevation, which the default is something like 6 degrees. Some of our projects that we schedule have thousands of sources potentially. And so scheduling them from an administrative point of view is not really possible. And so people are given time to observe, and it's up to them to make sure their sources are visible before they begin their observations. And so they can use a function like that. I showed you some pointing scans right at the beginning. Pointing the GBT is actually very simple in its most simple format. We have these auto procedures. So we have auto peak focus, auto peak, and auto focus, as well as auto oof, but I'm not going to get into oofing. Now they perform the system's utility calibrations. So you could just put auto peak focus, open brackets, into your script, and that would run, and you would run a pointing scan. Whether it would give you exactly what you wanted or not is debatable. You can put in a high level of customization. So you could choose the source you wanted. By default, the system will actually just choose the nearest pointing source above some default flux level. You can specify that flux level. You can specify how far you want to go on the sky before pointing. And it will also configure the system for continuum observations on its own. Or you can specify your own configuration, in which case you put configure equals false into your command. So yeah, as I said, there's a lot of flexibility, which means there's a lot of places you can make things go wrong if you really want to. Again, always talk to your project friend about any of these things that you're not sure about. As I said, if you want to, there is a lot of flexibility, and part of that means that you could actually just define your peak scan yourself. Some people want to tip the telescope. The gain of the GBT is very well known at most frequencies, so we very rarely tip as part of an observing project. Every once in a while, the staff will do so in order to check the gains, redefine the gains. That balance command is there again, and the balance on-off command I mentioned is there. What that does, it goes to your source, balances, goes off your source and balances, and splits the difference in the power level settings. Yeah, and these just give further access to the capability of the GBT. Now, there's a lot of flexible observing options. If you are frequency switching, for example, you might just want to track your object, then the telescope will just go to your object and follow it through the sky, taking data if you've configured it to do so. We have on-offs and off-ons. off on with the same hour angle. Dave brought up most of these, so I'm not going to spend too long on them. We have nod and subbeam nod. And then we have the different mapping options, including the daisy maps that Dave brought up. Now, that's all the slides I have. As I said, this would normally be a bit more interactive, and I'd be asking for hands up about various things and so on. But yeah, haven't really had the opportunity to do that, so I've sort of flown through this, which at least has given us some time at the end now to have any discussion that anyone wants. If there's any questions, I saw that there was one in the chat. Let me see if I can bring that up. And while I'm looking at that, if anyone wants to unmute themselves and ask a question, please go ahead. So, what's polarization switching? Is it switching which Stokes parameters you look at throughout the observation? So polarization switching is not something I've ever done or even I'm not familiar with, but actually no, it's switching between the left and right polarization of the receiver. So those each go into a different channel, and you would switch between those. See, can the configuration script be generated by Clio? I saw there is a spectral line configuration tool. Largely, yes. Again, that's something you would want to run by your friend. I think Amber, they may be able to go into that in more detail in the next talk. So Tony has Tony has answered the polarization switching question in a little more detail. Polarization switching changes the IF paths that the different polarizations go down. It is very useful for diagnosis issues, but not overly useful for observing, which will explain why I've never used it. Okay.
So we have 7 minutes or so before the formal end of this session and then a break. We'll hold on for another minute or so to see if there are any other questions. And then I believe Larry and Dave are good to stick around into the break if anyone has any detailed questions they want to ask, but we can also sort out some account issues.
Yep, certainly. Hey, Will, have you looked and see on the participants? Is everybody that you were expecting, are they on out of curiosity? Do we have our full groups?
There are a few people that I haven't been able to send connection info to, but only I think 4. So we're largely full here.
Okay, I was just wondering, the people watching right now, I see there's 54 participants, if that covers everybody in our groups.
There should be 50 observers.
Okay.
Split across the groups. So if there are no questions for Larry right now, thank you very much, Larry. And as I said, he'll stick around a little bit. Here's one. Is there a manual with all of the Astrid commands, or is the observer's guide the best reference?
The observer guides are currently our best reference.
So on the topic of accounts, if I did not send you an account and you didn't already have an account before the workshop, please stick around and send me a message. It's possible that I just accidentally skipped over someone. But I did go through beforehand and tried to see who already had accounts through their project friends or otherwise. So I will stick around for that. Everyone else, we will meet back together at 11:45 a.m. Eastern time, so in about 35 minutes.